Here is our second example with group data. And I want you to be careful here. We're going to find one extra thing with midpoints. So think back to the last video you just watched on the bowling pins, and we set up that chart. And we had the number of pins knocked down and how many times that happened. We're going to add one extra thing to this problem, one extra column. So here's our example. We want to find the population standard deviation example for heights of students. So imagine you have 20 students in a class, and you go ahead and measure all the students in the class, and you start to calculate their heights. We want to find what is the standard deviation of the heights in our class. So what we're going to do is we're going to group the heights. So the first height is 140 to 144.9, and we have to find one extra thing. We're going to find this midpoint of that set of heights, because there's some variation in there. So we say we average and we get the midpoint. How many students that happen to in that group is one student. Then the next group data is 145 to 149.9. And we average it, we take the midpoint, and there's one student that went into that category. Then we say 150 to 154.9 inches, and we get 152.5 is the midpoint, and there were two students that fell in that category. And then 155 to 159.9, we took the midpoint. Remember, midpoint is outside two numbers and divide by 2, and we got 6 students. Okay, so we will continue with that chart all the way through. You're setting up your data. Now, this is your X. We're going to ignore that column now. And we're going to continue like we did in the bowling problem. So that's our X is the first column. Now what we did is we found out the frequency. We totaled this values up. So there were 20 students in the class that we went out and measured their heights. And then, if you remember from the bowling problem, we took the frequency times X. So 142.5 times 1, 142.5. Then we took 147.5 times 1, 147.5. And we did that all the way through that third column there. And we now have the sum of f of x. Then the next column, we square x squared. So what that means is take 142.5 and multiply it to itself, and now you're getting some pretty big numbers. And you would take 147.5, multiply itself, you get that number. Okay. The last column is to take your frequency times your x squared. So 1 times 20,306, and you get 20,306. All right, there's our last set of numbers that we need. We'll continue through. Again, pause and write this stuff down. Maybe try and doing it yourself to see if you're getting the same numbers. All right, now we're set to use our formula. So we want to find the standard deviation. So I'm just going to erase these here and see what we're working with. So we have the sum of f of x squared, there it is, minus the sum of f times x, and we're going to have to square that. Make sure you square it. Then we have the sum of our frequency, minus 1. Throw it all into your calculator. Take your time, be careful, and you get approximately a standard deviation of 38.33. So the standard deviation is 38.33 centimeters.